Apple, the richest company in the world, just stepped into the world of language models. A company not known for its openness just released their OpenELM model family with an open-source training and inference framework, but why is it so important? Remember when the first M1-powered Mac was announced? The promise was not only about a performance boost, but also about efficiency. Same goes with this language model. But how? Let's find out. So, in the last days of April, Apple took to its official website and announced the release of an open, efficient language model with an open-source training and inference network. The release featured the names of all the critical development personnel and established how transparency and reproducibility of large language models are of utmost importance to ensure the trustworthiness of results. The announcement also touted the efficiency and accuracy of this model, which arises from the fact that it makes use of a layer-wise scaling strategy to efficiently allocate parameters within each layer of the transformer model. Apple further exemplified this strategy by mentioning that with a whopping budget of around 1 billion parameters, OpenELM flexes its muscles with a 2.36% boost in accuracy over Olmo, a previous model from Apple, all while using just half the pre-training tokens. Apple has also claimed to abandon previous practices that solely provided model weights and inference code and exclusively pre-trained on confidential datasets. The company added that the release encompasses a holistic framework as it facilitates both training and evaluation of the language model on datasets accessible to the public. In totality, the release consists of training logs, numerous checkpoints, and pre-training configurations. Additionally, Apple has provided code to convert models into the MLX library for inference and fine-tuning on Apple devices. MLX framework was unveiled last year for running machine learning tasks on Apple's silicon, offering a compelling advantage. Its capability to function directly on Apple devices without relying on network connections is poised to heighten developer interest in OpenELM. According to Apple's website, this comprehensive release aims to bolster and empower the open research community, laying the groundwork for forthcoming open research initiatives. Now, the question pops up, what is Apple actually trying to do with this model? And secondly, how good is the model? To answer the first, Apple's presence on Hugging Face suggests they're gunning for on-device applications, joining the ranks of Google, Samsung, and Microsoft. Microsoft also dropped its Phi 3 mini model this week, boasting full smartphone functionality. All these releases pushed Apple to step up their game, which result in the company's packaging of their release. Apple's OpenELM models come in 8 configurations and 4 sizes, i.e. 270 million, 450 million, 1.1 billion, and 3 billion parameters. These sizes are smaller than many high-performing models, which usually have around 7 billion parameters. Each size comes in both pre-trained and instruct versions. According to the likes of Reddit, Wikipedia, Archive.org, and more, these models were pre-trained on public datasets comprising around 2 trillion tokens. All the data was acquired from publicly accessible datasets, including Wikipedia, GitHub Text, Refined Web, a deduplicated version of Pile, a subset of Red Pajama, and a subset of Dolma version 1.6. Thanks to the extended training, these models can actually generate human-level conversational text. These models can run smoothly on regular laptops or even certain smartphones. Apple conducted benchmarks on a workstation with specific hardware specs, including an Intel i9 CPU and an NVIDIA RTX 4090 GPU with 24 GB of video RAM running Ubuntu 22.04. They also tested on an Apple MacBook Pro with an M2 Max system on chip and 64 GB of RAM running macOS 14.4.1. Remarkably, all models in this new lineup utilize a layer-wise scaling approach to distribute parameters within each layer of the transformer model, which we discussed earlier. Apple claims that this strategy enhances accuracy while maintaining computational efficiency. The models were pre-trained using Apple's new CoreNet library. In terms of performance, Apple's OpenLLM results indicate the models perform admirably well, with particular praise for the 450 million parameters instruct variant. To be specific, the 1.1 billion OpenELM variant is the one that outperforms Olmo, which has 1.2 billion parameters while requiring twice as few pre-training tokens. The pre-trained OpenELM 3B variant achieved an accuracy of 42.24% on the ARC-C benchmark, which evaluates knowledge and reasoning skills. It also scored 26.76% on MMLU and 73.28% on HeliSwag. In terms of real-world performance, a Twitter user pointed out that these models are good, but they are very aligned, which means that the responses are almost never creative and never enter the NSFW territory. If we compare Apple's release to what Microsoft has to offer, we see that Microsoft's Phi 3 currently takes the lead with its 3.8 billion parameters and 4K context length. So now that we have all the technical details sorted, why not discuss the implications of this release and what it actually means for Apple? Apple's decision to release the source code, model weights, and training materials is motivated by its desire to empower and enrich the open research community. Nonetheless, the company issues a cautionary note acknowledging that because the models were trained on publicly sourced datasets, they could generate inaccurate, harmful, biased, or questionable outputs in response to user prompts. Apple's dedication to on-device AI resonates with its privacy-centric ethos. OpenELM is designed to operate on smartphones and laptops, minimizing dependence on cloud-based computations. This stands out as a notable benefit for individuals valuing data privacy and security. Not only that, but it's also another step forward in energy conservation, since cloud-based applications usually result in substantial power expenditures. Moreover, Apple's initiative to open source these models on Hugging Face fosters community collaboration and transparency, empowering developers to explore diverse applications catering to many real-world scenarios. The model's compact size, varying from 270 million to 3 billion parameters, renders them well-suited for low-powered devices. This further ensures efficient execution without significant resource consumption. This appeals to developers seeking to incorporate AI into mobile applications without compromising battery life or processing speed, as it is more powerful than most of the BERT models. Despite acknowledging Apple's commitment to energy efficiency and privacy, many experts argue that this release misses the mark. The first thing that OpenELM's performance is lacking compared to Microsoft's Phi 3 Mini, boasting 3.8 million parameters, which surpasses even OpenELM's largest model. This performance disparity suggests that Apple may not be positioned to compete at the top tier of the AI spectrum, potentially restricting its adoption for more niched applications. Another critique is that the release of OpenELM seems more like a PR move than a significant technological advancement. Apple's recent decline in stock price, attributed in part to perceived shortcomings in AI innovation, might have driven the company to unveil something to regain public attention. Nonetheless, the model's restricted performance and absence of distinctive features compared to competitors indicate that this could be an effort to maintain relevance without delivering substantial value. OpenELM's dependence on public datasets also brings forth concerns regarding the quality and diversity of the data. This could potentially introduce biases or constraints in the model's capabilities, rendering it less adaptable for a range of applications. Not only that, OpenELM seems to lack a distinctive niche, entering a market already occupied by established players boasting superior models. The internet has been buzzing ever since Apple's original announcement. Some hot takes from the developers suggest that Apple's OpenELM appears to be a squandered chance to capitalize on the company's resources and Silicon Valley prowess. Instead of forging ahead with a groundbreaking AI model, Apple has put forth a collection of models that lack distinction in terms of performance, application, or innovation. This PR-driven rollout may hint at Apple's uncertain AI strategy. The company has been hesitant to fully embrace AI in the public eye, and OpenELM fails to articulate a clear long-term vision. This lack of clarity may breed skepticism among developers and inventors regarding Apple's dedication to AI. Many experts on Reddit and Twitter suggest that navigating the balance between privacy and performance is a delicate matter. While Apple's focus on privacy is admirable, the compromise on performance may not resonate well with developers and users in search of advanced AI capabilities. Some more optimistic individuals suggest that OpenELM could serve as a starting point, but significant improvements are needed for it to compete effectively in the ever-evolving AI landscape. As of Apple's future in AI, it is meant to be bright. This is because we cannot forget that back in October of 2023, the company grabbed attention with the discreet launch of Ferret, an open-source language model equipped with multimodal capabilities. Apple worked in collaboration with Cornell University to craft this model as it merges computer vision with natural language processing, enabling it to chew through images and text and spitting out responses to mimic human-level assistance. Ferret is being built to handle complex tasks, dancing through conversational image understanding and tag-teaming visual and textual info. Ferret also comes in two configurations, a 7 billion parameter model for iOS gadgets and a beefier 13 billion parameter model for more powerful computing devices. Apple has taken a generous step by making Ferret available for exploration by researchers and developers, allowing them to delve into its inner workings and contribute to its evolution. The company claims that Ferret boasts aces in spatial referencing, which enhances the user's experience, making interactions with AI feel more intuitive and natural. Additionally, its proficiency in various UI tasks, such as icon recognition and text spotting, positions it as a valuable asset for navigating mobile interfaces seamlessly. The potential applications of Ferret are vast and diverse, ranging from enhancing smartphone interactions to streamlining app texting processes and improving accessibility for users requiring additional assistance with technology. Ferret's release is primarily for research purposes at the moment, but the existence of such an undertaking highlights that Apple might seem slow and defeated currently, but this may not be the case in years to come. Subscribe to AI Symbiosis for more AI news and updates. It feels as if top tech players are trying all their might to notch up their game in LLMs. Meta has just released their third iteration of Llama, and it is giving nightmares to industry leaders like OpenAI, Microsoft, and Google. To find out how, click on the video link popping up, and we will catch you there in a second. See ya!